So today we're going to be doing the first part of chapter 2. It's operating systems. Introduction to operating systems. So what are the functions of the operating system? The first one is to oversee the operation of a computer, and the second one is to store and retrieve files, and the last one is to schedule programs for execution. Now, in the operating systems, we have something called the batch processing, and I will explain it to you via an aid of a diagram. Alright, so this is batch processing. Now, batch processing is the form in which you handle more information in batches. These are individual processes, and these are batch processes. Here you have an output or results. Now let's take this area right here as a user-defined area. Let me use another color. This right here is a user-defined area, and this one is a computer-defined area or machine-defined area. So I'm going to make an example with gym membership payments, or maybe credit card payments. Membership or members. And these members have to pay a monthly fee each and every 30 days or each and every first day of the month. So the information is stored in this area right here. When the information is stored in there, it has to go to do the job, and it will be queued, job queue. If you choose to process the information individually, in JavaScript, usually we do for each. Now, for each member, you're going to take or iterate through each and every person individually, which is going to take more time. Another example, let's say you have member 1, then you have member 2, and then you have member 3. Let's assume that member 3 and member 1 are doing the same thing. They have the same membership program, and they have the same sets that they do each and every gym visit, right? Again, I'm doing for the individual part to not confuse you guys. The system is going to do or to oversee member 1, then it executes the job right here, right? Now it's done. Oh, this is too large. After the first member, it's going to go to member 2. And then after member 2, it does what it's doing. It processes the information and so on and so on. And then after member 2, it goes to member 3, and so on. In the individual part, it's going to take a long time and a lot of memory to go through all the members. Assume that we have more than 500 members. It's going to take a lot of time to achieve the distribution of all members and categorizing them in the same category or different categories. Okay. Now, for a faster version, we do batch processing. We have member 1 and member 2. Member 3. Now, how this works is like this. Member 1 has attributes. Like I said or mentioned, their gym membership type and whatsoever. It's going to take that category of gym membership type and then it's going to search for the same membership type over and over until everything is done. In this case, we only have member 3. So member 1 will be associated with member 3. Then the job process is going to be iterating for 1 and 3 at the same time, right? So in that way, So in that way, it'll be quicker and more effective rather than just iterating one by one, right? So we take a badge and queue it. Then the queue is going to iterate for every category, same category, not a person individually, so same categories simultaneously. And then it's going to be executed, and the results are going to be taken out. So in a form of, let's say, the first one has a membership, let's say premium, the second one, the standard and whatsoever. It's going to be collected and sorted in that way. That's how batch processing works. Now, the second process is called the interactive processing, whereby I'll just make an example. I can explain it in a way that I also can understand, but let's put it like this. You go to a shop, or let's say ShopRite for argument's sake, and then you buy something. The moment you go to the cashier and the cashier scans that thing, it's called an interactive process, which is also known as a real-time processing. Real-time processing. Sorry. Now, for the definitions, I don't think there are any definitions, but they may ask you to define batch processing and interactive processing. Now, let's move to the advantages of batch processing. The advantages and disadvantages. Right. So the first advantage is also a disadvantage in batch processing, as it runs in the background, and as it's running in the background, it's using more power, so it is costly or expensive. I'm just going to name these two because I'm certain that the other ones I'll be wrong about them. Then let's move to interactive processing or real-time processing. Now, interactive processing, as I explained, it's just what you're doing with your devices and how they respond to you. They respond to you in the same way, or at the same time, at the very same time that you click them. Let's say you open an app, maybe you're going to write something on WhatsApp and whatsoever, right? I don't know a lot about interactive processing, but I can surely name the advantage and disadvantage of this. Now, for the advantage is that everything that happens in real time. It doesn't delay. And as things are happening in real time, they are time consuming. So every advantage has a counter advantage. It happens in real time and it takes a lot of time as it's filled with repetitions. And what I mean by this is the superstore, for example, they're scanning your items in real time. And maybe let's say you have like 5 packets of chips. Maybe it's going to take a lot of time to scan these 5 packets, rather than in batch processing where it's just scanning and then you input how much of something you have. Let's move to time sharing, which is a technique of dividing time into time slices or into intervals. Now, time sharing takes one job per time slice. Just like I mentioned here, it falls under interactive processing. It takes one job per time slice. It happens in real time and it takes a lot of time as it's filled with repetitions. One job per interval. And jobs take 10. They don't happen all at once. And then again, you may be asked to differentiate between batch processing and interactive processing. So for that, I think you need to do your researches on that so that it doesn't surprise you when it comes in tests and examinations or quizzes. In interactive processing again, we have multitasking, which is time sharing in a single user system. And there is a concurrent execution of more than one program at a time. So you can open your Word document, you can open your spreadsheets, you can open any application that you want because you can multitask. It's a concurrent execution of one or more programs at a time. And the internal processing is first in multitasking. Then let's move to software classifications, whereby with an aid of a drawing, we have software at the top, in which it provides us with applications and the system software. And the system software provides us with utilities and the operating system. And the operating system serves us with the user interface and the kernel. Now, to remember this effectively, the first part is software, and then it gives us the application and the system. Then the system provides us with utility and the operating system. Then the operating system gives us the UI and the kernel. So you can go SES to UTOS to UI. SES to UTOS to UI. Now let's go to the other component, which is called the shell. And the shell is defined as the interface between the operating system and its users. So it's the one that translates information from the OS and makes it to be in a readable format for the users. Now, what this solely means is that it communicates with the user via the machine's GUI or graphic user interface and text. Whatsoever the operating system is writing in binary, it converts it to text in a readable format for us. Let me just mention that. It communicates with the users of the machine via the GUI and text. I can't actually draw the exact shell graphic, but I know that in the middle there's an operating system. The operating system just writes what it's writing, and then this part right here is the shell, and outside is us as the users. Now the shell takes whatsoever information is coming from here and gives it to us users. And when we users give the operating system information from our side, it first goes to the shell, then to the operating system. That's how things work in the operating system or the shell. The other component is going to be the window manager, which allocates blocks of space on the screen, called windows. Now, this window manager keeps track of the applications that are associated with each window. Like right now, I opened Notin, I opened WhatsApp, and I opened Brave. So each window is named by association. Now it allocates blocks of space on the screen called windows, and also it keeps track of the application, keeps track of which application is associated with each window. The other component, as mentioned, we have the kernel, which is an internal part of the operating system, and it performs the basic functions required by the computer installation. For example, it contains the file manager, it contains the scheduler and dispatcher. It also contains the memory manager, how memory is to be allocated between applications. The kernel is the internal part of an operating system. It performs the basic functions required by the computer installations, and it contains the file manager, the memory manager, the scheduler and dispatcher, and also the device drivers. Now, if you notice, we've done this in the first chapter. If I am not wrong, we did this in the first chapter, where we have the scheduler and the dispatcher. The dispatcher runs the programs that are in the scheduler, and the scheduler allocates space and time in which a program has to be executed. Let's talk about the file manager in the kernel. Now, the file manager just coordinates the use of the machine's mass storage facilities. It has the directory, which is often called a folder, and a directory path, which is defined by a sequence of directories within directories. Right now, the file manager coordinates the use of machine's mass memory. It includes the directories or folders, which are user-created bundles of files and other directories. So when you think of directories, if they do ask about directories, just say it's a user-created bundle of files or anything that is equivalent. Then again, we have directory paths, which are a sequence of directories within directories. Just think of it as a folder that is under other folders, a folder under a folder, and so on and so on. Then what's next? The device drivers. The device drivers are just storage units that communicate with controllers and nothing else. Then let's go to the memory manager. Now the last one, the scheduler and dispatcher. The scheduler just determines which activities are to be considered for executions. Now a dispatcher just controls the allocation of time slice to these activities. And that's going to be all in the components of the operating system. Now the second part is going to be bootstrapping or booting, the bootloader. In bootstrapping, we have the bootloader, which is a program in the read-only memory, and it is initially executed when power is turned on. So what actually happens here is that when the computer is turned on at that moment, it's going to transfer the operating system from mass storage to the main memory, and the operating system is going to just take charge. It's the same as, let's say I'm working somewhere and I have someone who runs above me. Now, when it's my shift, I'm going to stay there. The boss is not there. When the boss comes or when the boss arrives, he's going to take charge of that place. And then I leave, or maybe I'm just not important at that specific time that the boss is there. It's initially executed when power is on, and it transfers the OS from mass storage to main memory, and the OS takes charge. Now, with an aid of a diagram, you may be asked to draw this in the exam. I don't know if you have to explain the steps, but there is a possibility that you have to draw this. Here you have the main memory when the PC is turned off. So right here we're going to have a bootloader, which is under the ROM, and here we have the volatile memory, which is empty as the PC is off. When the PC is off, the storage disk, let's just say for argument's sake, this is a storage disk and it has the OS inside. So the machine starts by executing the bootstrap program already in the memory when this thing turns on, and the operating system is stored in the mass storage. When we go to the second one, this OS, this operating system, is going to be allocated space here in the volatile memory. So the bootloader program just directs the transfer of the OS into the main memory and then transfers control into it. This one now will just be unimportant. The bootloader, it will be unimportant as the PC has turned on. That's how it works. And here we have processes, whereby a process is just the activity of executing a program, and the process state is just the status of the activity. And the process state is just the status. Then other processes, we have the process administrations, where there's a scheduler, the dispatcher, the ready process, the waiting process, and so on and so on. I can't actually explain all of it at once, so I'll just refer you to the book, in which it will be on page 122. Let me just add this information. It's under the process administrations, in where the scheduler just adds and remove completed processes from the process table, and then the dispatcher just controls the allocation of time slice to the process in the process table. And the end of a time slice is signaled by an interruption. Just like when a song plays, the scheduler just says, all right, let's play this song. The dispatcher controls the allocation of the time slice, and then after that, the song ends. When the song ends, the other one doesn't just start immediately, not like that. It takes time, or a few seconds or nanoseconds delay. And then now we have a deadlock. Now, a deadlock is a process of blocking each other from continuing. It's the process of blocking each other from continuing. Now, in the process of blocking each other from continuing, we are either competing for resources, or we're just requesting for resources on a partial basis, or we're just allocated resources that cannot be forcibly retrieved. So the first one is competition for non-shareable resources. Number 2, requests of resources on a partial basis. And then the last one is just the allocated resources cannot be forcibly retrieved. Just like that. Now, for the competition of resources, we can take that example that the lecturer gave us on the slides. The trains, the 2 trains. The first train was like this, and the second train was like this. And this is a railway, and this is another railway. Now, this train wants to proceed to that side, and this train wants to proceed to that side. But it's not going to be possible because both trains are in each other's ways. So they are just competing for the railroads that are not shareable. And how do you handle competition for resources? You just have to make a control flag which sets or clears the path. Or you should have a group of instructions that should be executed by only one process at a time. And the last one is just the mutual exclusions. Find something called mutual exclusion, or maybe in your slides or the book there has to be something like mutual exclusion. Okay, now the last part is the security, whereby they happen because they are insecure passwords, or the reusing of passwords in each and every platform. Or the second one, which is the sniffing software that records activities and reports to intruders. Spyware, we like to call them spyware in the IT world, or malware or phishing softwares, viruses. Security, we have attacks from outside, whereby the problems or the attacks occur when you have insecure or frequently reused passwords. They also happen when you have a sniffing software which records activities. A way in which you can counteract these things is just getting an auditing software, which I personally would not recommend. Auditing softwares, they just make your computer run slow, and for the most part, some may be viruses. Again, I don't know which one it was. It was supposed to be protecting us as users, but then it was leaking information and using them, selling the information to third parties. I just forgot the software's name, but there was this one software. Now, to counteract it, get an auditing software. The auditing softwares just record and analyze activities from where and when the computer is being accessed, other than the place in which you normally access your computer from. Now, we have attacks from within, which are caused by unruly processes. And you can counteract this by controlling process activities via privileged instructions or privileged models. That window pop-up that comes up on Windows, which says, do you want to continue installing this app, or do you want to give this app admin privileges? You just have to limit those things most of the time. Control processes. This will mark the end of our lesson. Thank you.